Good day, all. This is Mathonsi, the author of Succeed in Electronics and Digital Concepts for Robotics, the book which we've authored with Brian Hendrikse. We will be sharing with you just the outline of the textbook, what it entails. We started writing the book. It was ECDR level 2 that was introduced in 2023. Now we are going to be looking at the new curriculum for level 3, which is going to be introduced in 2024. In the cover of this book, you can see it's written Succeed in Electronics and Digital Concepts for Robotics. We are going to be telling you what this book is all about. Let's go to the next slide and see. If you look at the next slide, welcome to Electronics and Digital Concepts for Robotics. EDCR aims to equip you with fourth industrial revolution capabilities through the transfer of trade-specific skills, knowledge, values, and attitudes. Level 3 consolidates some of the contents learned in Level 2 and continues with the practical and theoretical application of the learning material. There are 6 modules that are covered in this textbook. This module 1 about magnetism, electromagnetic circuits, and related concepts. Module 2, it's electrical supply systems, transformers, DC machines, and series parallel networked circuits. Module 3, it's electronic components and semiconductors. Module 4 is electrical components, symbols, circuit drawings, prototyping, and design. Module 5, it's all about electronic tools and equipment. And then module 6 is digital systems, PLCs, and principles. Going to the next slide, Introduction to Electronics and Digital Concepts for Robotics, EDCR Level 3. The subject introduction, Electronics and Digital Concepts for Robotics Level 3, covers the basics of electronics and is designed to introduce the field of learning. The assumption is made that the student has no previous electronics background. Electronics and Digital Concepts for Robotics transfers the necessary trade-specific skills, knowledge, values, and attitudes for students. Electronics and Digital Concepts for Robotics focuses on the understanding and application of electrical and electronic principles. The subject focuses on 5 main areas of specialization, namely its electrical power systems, electronics, digital electronics, mechatronics, and computer science. So it's a combination of all those 5 areas. The term mechatronics describes the integration of electronic engineering, electrical engineering, computer technology, and control engineering with mechanical engineering. This process forms a crucial part of the design, manufacturing, and maintenance of a wide range of engineering products and processes. Consequently, there is a need for engineers and technicians to adopt an interdisciplinary and integrated approach involving skills and knowledge that are not confined to a single subject area. They should be able to operate and communicate across a range of engineering disciplines. So that is just the basic introduction of this particular subject. So let's look at on the next slide. This here, we outline the weightings and the topic. We've got topic 1. In this module, students learn about the basic units measurements in robotics and how knowledge of atomic theory assists in the understanding robotics and engineering. Then topic 2, in order to understand the supply of electricity, it is important to know the terms involved, the calculation of different electrical values, and the comparison between different types of electrical supply systems. Topic 3, In this module, students will learn to identify circuit board components, understand their function, understand the application of these components, and their general construction. In topic 4, in this module, students will learn to read symbols for electronic components, how to build electronic circuits using breadboard and veroboards. Topic 5, this module will teach students how to use a range of measuring and testing instruments in the field of robotics. Lecturers should demonstrate the use of measuring and testing instruments in this module. Then the last module, which is topic 6, students will come to understand how digital electronics, Boolean logic, and logic gates operate and how they link to robotics. Going to the next slide, the recommended teaching times for this curriculum is the instructional offering is presented full-time over 2 semesters. It's spanning over 24 weeks each, not including assessments, just the teaching time. This is equivalent to 24, which is 2 times double periods of plus or minus 1 hour, 50 minutes. Plus 1 single period of plus or minus 50 minutes, 56 hours of plus or minus 4.5 hours per week, of which 36 hours are instructor-led contact hours, which also include the practical sessions. 18 hours are instructor-led contact hours dedicated to practical tutorials on PCs. In addition, a further 10 hours per term, which is plus or minus 1.5 hours per week, are required for students to practice on their own to reinforce and master practical concepts and skills. This should be accommodated in an open labs provided by the college. The physical resources that will be required for this curriculum or for this module to be carried out successfully, we need lecture rooms, training area or work area, which are the workshops in general. There should be ablution facilities, a safe storeroom of the equipment with enough storage spaces for consumable, suitable for storage. Funds from learning provider or funding bodies for the procurement of consumables, tools, and equipment need to be made available for the effective operation of a workplace involved in a training program. Students need to be individually equipped with the necessary tools. So these are the physical resources that will ensure that there is a success in carrying out of this particular curriculum. It is the R level 3. The weightings of the various topics are as follows. So we've got 2 papers. We've got paper 1, which focuses on theoretical component, and we've got paper 2, which focuses on design component. So meaning it's more of the student must know how to design. That is an external examination that we are talking about here. So we know that there is an ICAS, which means it is the tasks that are done throughout the course of the year. And then there is a final examination, which focuses on paper 1 and paper 2. So paper 1 is theory and paper 2 is design. So as you can see, topic 1 for all topics from topic 1 to topic 6 in a theoretical paper, they all have a weighting of 15%, meaning they equally have the same amount of weighting. So students must know all the work for theoretical parts. Then paper 2, design. Topic 1, they focuses on just smaller portion, which is 5%. Topic 2 is 10%. Topic 3, it's got a very big weighting of 30% with topic 4, which is 30%. Then topic 5, there is no design. Then topic 6, it's 25%. So when you are preparing your students, ensure that you focus on these weightings. It assists for which part that you need to strengthen the students on. Then the budget for this course, or rather for this module, Annual running cost, breakages and maintenance, regular service plan should be there. Insurance and internet connectivity, since it's more of electronic. The sustainability plan, to upgrade or replace the equipment every 4 to 5 years. So as we know, after 5 years, usually the equipment are not functional at the standard that is required. Then safety standards in terms of electrical points and distribution boards must be met. Such arresters should be installed. Since we are dealing with electronic and electrical components, we need to have a protection for our work areas. Electrical work within the computer lab must carry a certificate of compliance from an appropriate service provider or authority. All anti-thefts and fire safety measures must be installed in the computer lab. Network maintenance and management. Management plan. Colleges must have a management plan for the subjects that addresses the following: initial capital layout for setting up of a computer and electronics laboratory with the necessary work desks and layouts. The classroom setup, hardware and software requirements. The college must have funding available to provide the following: the consumables must be provided, electronic or electrical components that are used in different tasks, instruments, breadboards, vero boards, and so forth, different measuring instruments. In electronics and digital concepts for robotics, students are required to work individually on a computer lab during contact time and need access to the internet. A particular lab environment conducive to the presentation of robotics or electronic practical contents are also required. So if you look now at the contents of this book that we've written, myself, I've written module 1 to module 3, of which I'm gonna give you a detailed analysis on it or layout on it. And then Brian will continue with module 4 to module 6. I'm gonna start with module 1, which is magnetism, electromagnetic circuits and related concepts, which is the new module that was not part of level 2, since magnetism is the basis of electricity. So in here, it's more of about the foundations and the basis of electricity, which is magnetism, electromagnetic circuits, and related concepts. We've got 2 units in this module, which is unit 1.1, which is magnetic circuits, and unit 1.2, which is magnetism, electromagnetism, and electromagnetic induction. So in each and every module, we've got an opening page which has got learning outcomes, what student needs to know before the end of the particular module. We've got the module vocabulary, the key words that the students need to know. And then we've got the introduction of the module, which is the starting point, introducing the module accordingly. Then at the end of each module, we've got these 4 components, which is module summary, self-evaluation checklist, practical task, then the theory test for each module. Going to the second module, electrical supply systems, transformers, DC machines, and series and parallel network circuits. We've got the learning outcomes as well, module vocabulary, and the starting point. In this unit, or rather module, we are more focused on transformers, how electricity is supplied in South Africa, the devices that are used to supply electricity, and many other factors, the series and parallel connection of different types of networks. So that the focus is more on that. It's also a new module, especially transformers and their calculations. Is a new module that has been introduced. So we've got unit 2.1, which is transformers, focuses on transformers, and unit 2.2, calculations of transformers, unit 2.3, calculation using series paralleled network circuits. And then unit 2.4, calculations on the grouping of electrical cells, which was also done in the previous module, which is level 2. Then we've got a new module that was introduced, which is the good module that can assist learners to understand how to generate electricity using solar power. So this is unit 2.5. It focuses on solar cells, and it's one of the most critical modules that a student must understand, how solar cells are designed and how do they help in generating of electrical current. So that is the module that you should look out for. And then unit 2.6 is direct current machines, also, which is a new module which focuses on different types of machineries, motors, DC motors, and so forth. So and also DC generators. Then we've got also a module summary, self-evaluation checklist, the practical task, which focuses on a solar motor, which is one of the good practical tasks the student must be exposed to. And there are many other practical tasks that you can always go and check for in the internet so that the student may be exposed in various practicals. Then the last one is test your knowledge, which is a theory test. Then the last module that I'm going to be explaining is electronic components and semiconductors. We've got the learning outcomes, module vocabulary, and the starting point. Here we are focusing on electronic components that are used to build various types of circuits. We've got the resistance, unit 3.1, resistance of a material. Unit 3.2, the characteristics and operation of semiconductor diodes. Then unit 3.3, bipolar junction transistors. Unit 3.4, which is characteristics and applications of operational amplifiers. Then unit 3.5 focuses on capacitors in series and parallel. And unit 3.6, inductors in series parallel. And then the last unit focuses on controllers which sense and react to physical quantities. So there are a lot of controllers, especially in digital electronics. There are controllers that can be able to test the physical quantities and so forth. So this module, it's more on electronic components and semiconductors. And we've got a module summary, self-evaluation checklist. And then we've got also a practical activity, and then the theory test at the end of the module. So that is the modules that I have presented to you, the ones that I have authored. I will now hand over to Brian Hendrikse to continue with his modules, which is module 4, module 5, and module 6. Thank you so much for watching. Enjoy these subjects. It is the R level 3. It's a very exciting subject to teach. Thank you.
Hello, I'm Brian Hendrikse, and I will be doing module 4. Electrical components, symbols, circuit diagrams, and prototyping. First, we'll start again with Unit 4.1, where we'll do revision and reflect on what we covered in Level 2 of Module 4. For example, again, we'll look at the components, look at the symbols of the components, look at the symbols and see how we design circuits and prototyping of these circuits as well on breadboard. Then we'll go over to Unit 4.2, where we'll again do the symbols of different components, obviously introducing more components, and we'll use these symbols again to design circuits. For example, again, power supplies, half wave, full wave, transistors as a switch, transistors as an amplifier, op-amps, transducers, etc. We also do some prototyping of these circuits on breadboard. We'll not only do it on paper, but we'll also do it using software tools. Then we'll go over to designing simple circuits on Veroboard, building them, soldering them, and also on breadboard. And not only on paper, on a breadboard layout sheet, but also using software tools and testing these circuits. Then we'll go and do calculations on circuits. For example, resistors, series, parallel combinations, using Kirchhoff's laws and Ohm's laws. We'll then build these circuits on breadboard, insert ammeters, voltmeters, and verify our answers that our answers that we practically obtain is similar to those of the results we achieved when doing the calculations. Right through this module, we'll be doing theoretical and practical tasks. At the end of the module, we'll do some additional practical tasks and we'll do some projects as well. And then finally, we'll test your knowledge and give you a theoretical test and to see if you understood all the work we've covered in this module. Thank you. Right, then I start with module 5, electronic tools and equipment. Again, we'll reflect on what we covered in level 2. Again, starting with all the tools that we covered, like side cutters, long nose solder suckers, soldering irons, and all the instruments as well that we covered there, including the watt meter, the frequency counter, the clamp meter, etc. We'll then go and introduce Unit 5.2 electronic measuring instruments, and for the first time we're going to do the oscilloscope. Now the oscilloscope comes with first all the controls that you find on the oscilloscope will cover. Obviously the two most important, the time per division and the volts per division. All the switches that you see on the face plate of a oscilloscope, like the AC/DC switch, etc. Then we'll actually just look at this, simulate a sine wave on the display, and we'll do calculations, calculating the peak-to-peak voltages, the time period, and then eventually the frequency. We'll also introduce the signal generators, one being the function generator, connected to the oscilloscope and display a sine wave, sawtooth waveform, square wave. Right, then we'll move over to how to use and carry a held-down measuring instrument. So what we'll do is look at all the different instruments, see how would you carry it, for it, and how would you use it. How would you use a oscilloscope? How would you use a function generator? What would you use it for? How would you use a frequency counter, a clamp meter? How would you test a diode? How would you test the voltage? And then right through this module as well, you do practical and theoretical tasks. At the end, again, you'll do a practical task and a theoretical test where you'll test your knowledge and see if you did understand everything in this module. Thank you. Right, then module 6, digital systems, PLCs and principles. Here again we'll do logic gates. We'll introduce new logic gates like the NAND gate, the NOR gate, the exclusive ORs. We'll study the truth tables of them, the symbols of them, different applications, drawings, how to connect them to do different applications, and then analyze them on data sheets. Unit 6.2. Here we'll introduce the PLC, Process Logic Controller. We'll physically look at what it looks like. We'll look at the internal structure of it, be able to draw a block diagram of it, knowing the inputs, the outputs, the CPU, the memory, battery backups. And we'll also compare this PLC to the old system before it arrived, the relay system. We'll also look at the advantages, disadvantages of the two. And then the programming of the PLC, ladder diagram logic. Knowing, can you interpret a ladder diagram logic? Can you design a ladder diagram circuit? And then last is your logic design. Here you'll read a scenario and you'll be able to design a logic circuit that will satisfy that scenario. Right through this module as well, you'll be doing different practical tasks as well as theoretical tasks. At the end, again, you'll do a practical task and a theory to test if you understood everything. Thank you. Right, the internal assessment and weighting. Here we've got components, the internal assessment and the external assessment. They both count 50% weighting. The one is called the ICAS, the other one is the ISAT. The ICAS counts 50%, and I'll give you more details about the ICAS later, and the ISAT, which counts 50%. You'll also write the external examination, which counts 35%. Added together would be 100%. The ICAS comprises of 2 theoretical tests, which count 10 times 2, 20%. Practical assessments, which count a little bit more, 2 of them as well. They're 25% each, 50%. And then normally in September you'll write an external examination, and that counts 30%. Thank you. National assessment and weighting. If we look at the first table there, we'll see level 2. We did 2 different papers, a theory paper and a design paper. The one counting 100 marks, the other one counting 80 marks. Again in level 3, you're doing the same. A 100-mark paper, 3 hours, and an 80-mark paper, which they'll also give you 3 hours to do, design related. It will cover all the topics. The theory paper will cover all the topics. The design paper will cover everything except topic 5. Thank you. Here's a sample of a national exam for paper 1 and paper 2. Let's first look at paper 1. But let's just remember a sample paper. Now question 1, 2 and 3 is on all the modules for this sample, counting 10 marks. Now that means that it'll either be true, false from all the different modules, or it'll be select the correct word from all the modules, or it'll be match table A with table B, or it'll be choose the correct answer, A, B, C, or D. And then the next 6 questions will be on a question on each module. Paper 2 will be design related. So obviously there'll be questions where design a breadboard layout, design a variable layout, design a circuit, and there is the modules and the time and the mark allocation. Right. Thank you. Right, I hope you enjoyed this. And I thank you. Enjoy the rest of your day. Thank you. Bye-bye.